Okay. Hello everyone, welcome back to the lab again. This time we're doing class 15 lab. In this lab we're going to basically characterize an LED. So we're going to have a red LED over here. If you see the red LEDs over here. LED is a polarized device. That means it has positive and negatives. How you know that which side is positive, which side is negative? LED has two legs, right? So this leg is longer. That means this is positive, shorter leg is negative. Also, if you cut them equally, then how do you know it's positive or negative? If you go around here, there should be a plain side on this side, on the negative one here. It's hard to see. There's a plain side on this side over here. If you can feel with the finger, that is your negative, right? And also, if you can look at inside, there are two parts of the LEDs connected to two different legs. The smaller part, if I can see, it's very hard to see. The smaller portion of it is normally positive, all right? So for the first lab, we're going to do two different setup here. One is we're going to apply positive voltage. That means your positive leg would be connected to positive voltage. Negative leg would be connected to negative voltage. That means applying positive voltage. And second one, we're going to apply negative voltage. That means we're going to connect negative part of the LED to the positive voltage and positive part of the LED with negative voltage. So first, we're going to apply positive voltage up to 2.2 volts. And I also have the current limit 0.5 from the power supply. So here I made a chart for voltage I1. So for the positive one, I'm going to go from 0 to 2.2, increment of 0.2. You can have different increment if you want. And for the negative voltage, I'm going to go 0 to negative 4.4. I'm taking 0.4 increment for that. All right. So now let's put it over here. So LEDs for the first one, positive voltage applying. So positive one goes to positive here, and negative to go to negative. So positive here, negative here, and positive voltage coming. I'm measuring current through the emitter, so emitter in series. Look at here coming for the positive, going into the current measurement, and common coming to the positive side here, and going back to the power supply. So over here you can see that I have a 0.5 amp current limit, all right, and I'm going to go back to voltage increment here. So I'm going to turn it on. If I turn it on, 0 volts, 0 current, right? So I'm going to have 0 volts, 0 current here, 0 amp, right? Then I'm going to increase the voltage by 0.2 here. Still no current. Look at that. There's no current. Still 0 amps. I'm going to increase to 0.4. Still no current, right? And I'm going to increase to 0.6. Still no current. You can see there is still no current. I'm going to go into 0.8 now. I still don't see any current, right? Now I'm going to go to 1 volts here. I still see no current. Then I'm going to go into 1.2. Still, I don't see any current. 1.4. I try to see a current, but still I'll take it as 0. I just flickered for 1 milliamps. Then I'm going to go to 1.6. Still, I don't see any current. And 1.8, I see 1 milliamp there. All right, and 2, I see 2 milliamp there. And if you close up, you can see that the LED is lighting a little bit. If you bring it close up here to LEDs, it's trying to light up. You see that? So now I'm going to go to 2.2 now. 2.2, still I see 2 milliamps. For curiosity, I'm going to go a little bit higher. Your light LEDs basically lights up right now a little bit. If I go 2.4, I see 3 milliamps there. If I go 2.6, it's more lights up now. You can see the LED is brightening right now. 2.6 is 4 milliamps. 2.8, I see 4 milliamps still, but LED lights up now. So I'm going to stop here. So if you go further and further like that, you might destroy your LEDs, okay? So I'm going to stop here. This is the positive one. So that's all for the positive one. I'm going to go back to the negative one now. Okay, for the negative one, what I'm going to do, I'm going to flip this. So now the negative side will be connected to positive. So I'm going to flip it here. So negative side is connected to positive, and positive side going to the negative side, okay? Right here. So, and I'm going to go back to my 0 voltage. All right. Then I'm going to start cranking it by 0.4 right here, as you see, my table here. See that my table here is, I'm cranking with the 0.4 increment. So turn it on. So now zero current, obviously. And you go 0.4, still zero current. 0.8, zero current. 1.2, zero current. 1.6, zero current. 2 volts, zero currents. 2.4, zero currents. 2.8, right? 2.8, zero currents. It's all negative. And 3.2 is also zero current. 3.6, zero current. 4, zero currents. 4.4, also zero current. So you can see that here in the reverse direction for LED, there's no current. That means LED cannot contact current in ideal case in reverse direction. There's no current, there's not lighting up. So LED's unipolar device is only can conduct current in one direction. If you force higher voltage in reverse direction, it's going to destroy your LEDs. So it not be useful anymore. That's all for the lab, and see you guys for the next lab.